So today we're going to look at radical expressions. First I want to kind of go through the different pieces of a radical so that way you're not confused. So whenever I talk about a radical today, I'm talking about this little shape. This is called a radical. Underneath that radical, you have variables and numbers, so combinations of variables and numbers. This is called a radicand. And there's a number that sits right on top of the radical. Usually you don't see a number, so like in this case, it would be an imaginary 2. Sometimes you'll see a 3 or a 4 like you're going to see later on in this page. So this is called your index. All of this information is meant to be a review of Algebra 1 and what you saw before you got into Algebra 2. So if you don't remember this information, pay attention. If you do remember this information, go through it and see what stuff you remember how to do. So in this top section, we're just going to simplify radicals. So all 4 of these questions are here. All of them are square root though. Since we're about to talk about square root and cube root functions, I'm actually going to add in a couple more questions here, and that's going to be for questions 5 and 6. So for question 5, I'm going to add in the cube root of negative 96. And then for question 6, I'll add in the cube root of 250. There's methods to my madness. So in this question, first we're going to look at example 3. So I'm going to do 3, 4, 5, and 6 right now. For question 3, we're going to take the square root of 125. So over here to the side, I'm going to break up 125 into nothing but prime numbers. So you have a calculator. First thing you want to check is to see if 125 can actually be square rooted. Okay, well in order to do that, I just typed in 125 and hit the square root button. Okay, that gives me a decimal. You don't want to have to deal with decimals when you're simplifying. So for 125, I can break this up into 5 and 25. 5 is prime. And 25 can be broken into 5 and 5. So underneath the square root of 125, I can rewrite it as 5 times 5 times 5. What's the index on this radical again? I just said it. 2. If you don't see it, it's a 2. So that means if I can group 2 of the same number together, so like these two 5s, I can help it escape from this radical prison. So when I do that, this 5 will go away. Every single time you have a group, only 1 is going to make it out. Even if there were 6 different things circled, I would just make 1 escape. So we're going to write our simplified radical as 5 square root of 5. This would be your answer. For example 4, right underneath it, same thing. So over here to the side, with my calculator, I'm going to try to take the square root of 21, which, gross, I can't. So I'm going to take 21 and split it into nothing but prime numbers. So, Sandra, what 2 numbers can I multiply to get to 21? And by the way, guys, you have a calculator today, so make sure you use them. What times what will give you 21? 7 and 3. Good. 7 is prime, and 3 is prime. Prime, it just means it's divisible by 1 in itself. Okay, well, those are the only 2 numbers, so I'm going to rewrite 7 times 3. And it doesn't change. I know that there's an imaginary 2 that sits on this radical, but I can't group them. They're not the same. So what we're going to put here is you could either put it as a square root of 21, or you could write that it's already simplified. Haven't decided yet or know yet how we're going to write it on your tests and quizzes, but you could either rewrite the exact same answer or you could write out simplified. That means that you cannot simplify it any further. If you have this on tests and quizzes, it's not a joke. It's not there to fool you. Alright, for question 5, we have the square root of 96, negative square root of 96. Square roots, you can't take negatives. You can't deal with any negative values. For cube roots, though, you can. So for the cube roots, we're going to do, this is the same thing as negative 1 times 96. That's technically what that is. So I'm going to treat this problem as it's the cube root of negative 1 times the cube root of 96. Okay, well, the cube root of negative 1, I think you can take it. In your calculator, I'm just going to type in negative 1. So I just typed in negative 1, hit 1 first, then the negative symbol. And then I'm going to cube root it. The cube root symbol is in green on your calculator. So look through it and see where you can find it. For my calculator, it's all the way down here at the bottom. So it's at 0. So if I were to take the cube root of this, I would hit the green button first. Let me zoom out a bit. Green button first, and then 0. And it actually took the cube root already. If you don't believe me, let's try the cube root of negative 8. Cube root of negative 8, you would just hit the green button and 0, and it's going to give you the cube root. So again, if you do the cube root of -1, green button 0, it's going to give you -1. Because -1 times -1 times -1 is just -1. Let me borrow your calculator. For the silver calculator, looks like this. If you were going to take the cube root, your cube root button is right up here at ln. So if you were to do this, I'm going to type in -1, and I'm going to hit the green button, ln. It already takes that cube root. If you don't believe me, try typing in -8 in this silver calculator. So green button, ln, and it simplifies to -2. This one gives you more of a suspense because it actually clears it to show you what your answer is. But the gray one does the same thing. Thank you. Okay, so we already saw the cube root of -1 is just -1. So I'm going to keep that in mind. 96, though, I do need to break up. So 96, I'm going to break up into nothing but prime numbers. Okay, 96 divided by 3 is 32. So 3 and 32. 32, I can break into, let's see, 6 and 4? No. Oh, 8 and 4. Okay, yes, 8 and 4. What does 8 break into? 4 and 2. 4 breaks into 2 and 2. Square root of 4, or not square root of 4, 2 times 2 will give you 4, so I'm going to break up 4 one more time. Underneath this radical, or technically this one, I'm going to rewrite the cube root of, we have -1 times 1, 2, 3, 4, 5 2's, and 1, 3. So take a second and look at what I did. Both of these mean the same thing. You're multiplying -1 times, that little dot is times 96. If you put that x for times, I will take off points because I will think it's an x. All right, let me double check. I can make a group of 3 this time. We have an index of 3. We can take the cube root of -1, because what's the cube root of -1? -1. So anytime you have -1 there, guys, just circle the -1 because you know the cube root of -1 equals -1. I have 1, 2, 3 2's that I can group together. 1, 2, this stupid 3 is preventing me from grouping it. Oh well. All right, so I can only escape one group of 2's. From this big ugly group, only 1 2 is going to make it out. So here's my final answer. We have -1 and 2 that escape, so we're going to make this -2. Cube root of 2 times 2 times 3. When I get lazy, I don't put the multiplication, but understand you're multiplying. 2 times 2 is 4. 4 times 3 is 12. This is your final answer. One last annoying Miss Tapia comment. Cube root, if you don't put that little 3, guys, I will take off a point because I will assume that it's a square root instead of cube root. Yes, ma'am? Because you see how this -1? Joseph just confirmed with me that the cube root of -1, which we did in our calculator, gives you -1. So I take the -1 out, so -1 comes out, and then this 2, there's 3 of them in your group, only 1 can make it out. So just -1 times 2 is -2. Do number 6. There's no negative. If I put a negative, you could still do it though. Split up 250, because trust me, 250, if I was to take the cube root, green button, 0, it doesn't give me a whole number. So do 250 right now. Break this up. And don't start with 2. 25 times 10 will give you 250. It'll go a lot quicker.
Why does it become imaginary?
Because when you do square roots, that's the only time it becomes imaginary, because -1 times -1 doesn't give you a -1. Only -1 times -1 times -1. Imaginary deals with square roots. So if we were doing the square root of -1, that gives you an imaginary number, because there's not a possible number to multiply 2 times to give you a -1. Does that make sense? Okay. Square roots have imaginary, really even roots. Even roots have imaginary numbers. Odd roots do not, because odd roots can handle the negatives. Okay, 250. I said 25 and 10. What does 25 break into? 5 and 5. What about 10? 5 and 2. So I can rewrite this as the cube root of, and I wrote it underneath, so I'll keep that up. Cube root of 1, 2, 3 5s and 1, 2, not a 3. Make this a 2. Since the index is a 3, I can group 3 of the same number together and help it escape from this little radical prison. So this doesn't make it out, neither does that one. Only one of the 5s do, and the cube root of 2 stays there. Be careful when you're writing this out. If you need to put a parentheses around what your radical is, you can. I won't take off points if you don't, but if you're afraid that you can't tell or I can't tell which one is your index and which one is an exponent, you can put it in parentheses. All right, adding and subtracting. Let's look at the bottom part. For adding and subtracting, I'm going to do the questions that are on that bottom portion, and I'm going to adjust one as well to make it a little nicer. All right, for adding and subtracting radicals. In adding and subtracting radicals, there are 3 steps that you need to follow. First, you're going to simplify all your radicals, so this part will suck a bit because you do have to simplify all your radicals first. After you simplify your radicals, you're going to identify radicals with the same index and radicand. Let me move that over. Same index and radicand. Only those can be combined. So if you have like the square root of 2 and plus the square root of 2, you can combine those. But if you have a square root of 2 and square root of 3, can't combine them. The last piece, for only the common radicals, so for only the common radicals, add or subtract your coefficients and keep the common radical the same. It seems like a lot, but we're going to work through it together. There is one question right off the bat that I want you to edit if it's not already edited on your page. For question 4, there's too many 4th roots, and I'm kind of lazy. So let's remove that 4th root from 72. Just scratch that out. Just scratch that out so that way you don't have to worry about it. So we're just going to pretend like that is a square root instead of a 4th root. There's specific names for 4th root. I just don't care to know it. Didn't need it in college, don't need it now. Let's look at example 1. Example 1 explicitly states, based on the directions, you simplify first and then find the radicands and index that are the same. So for this question, first thing I'm going to do is simplify both of these radicals. So we have 27 and 12. I need to break both of these up. Okay, 27. I can break that into 9 and 3. 9 is prime, or 3 is prime. 9 can break up into 3 and 3. So from here, normally I put the radical that I need to simplify under here, but since there's 2 different ones, I'm going to simplify it in this space. We're going to take the square root of, and I'm putting that index so you can remember what it is, 3 times 3 times 3. Since your index is 2, I can only group 2 of these together to help them escape. One of the 3's doesn't make it out. So the simplified radical for the square root of 27 is just 3 square root of 3. Do the same thing for 12. There are plenty of ways you can simplify this. You can draw the tree out completely, or you can simplify as you go. I like the tree better. For 12, you can split it into 4 and 3. If you're good and you know what to do from here, you can take the square root of 4, because what's the square root of 4? 2. So you could technically stop here, take the square root of 4, and keep the 3. Square root of 4 is just 2 square root of 3. If you keep simplifying here, guys, 4 is going to break up into 2 and 2. You're still going to get this 2 square root of 3. So let me replace this 2 square root of 3 and 3 square root of 3 with both of these radicals. Okay, so on your paper, in this space, so hopefully it's completely blank over here, we're going to make it 3 times the square root of 27 minus 2 times the square root of 12. Itzia, what did the square root of 27 simplify to? And what did the square root of 12 simplify to? So with that in mind, how do I simplify that? What can I do? Which 3? This 3 or this 3? First or second? First one, yes, it's exactly what you were supposed to do. Good job. We're going to multiply the first 3 and the first 3 here. So these 2 are going to become 9 square root 3. And then you're also going to multiply 2 times 2. So minus 4 square root 3. Good job. One last thing, Itzia. Do your index and radicands match for both of these? Yes, the index is an imaginary 2, the radicand is a 3. So based on the directions, we can add and subtract our coefficients. Keep the common radical. So we're still going to have the square root of 3 in our answer, but what's 9 minus 4, guys? That's your answer. If you don't remember this from Algebra 1, this is why I'm doing it. All right, I'm going to do 54. I'm going to break that one apart. You guys do negative 16. So right now I'm giving you a head start. You guys do 16, negative 16. I'll simplify 54. Before you start to simplify, for cube root of 2, do I need to simplify that? Why not for what? Say it again. You can't do anything with it. What's the multiples of 2? Itself and 1. 1 times 2 is going to give you 2. You can't simplify this. So just leave it as cube root of 2. You can't simplify it. So you guys right now simplify the cube root of 16. I'll simplify 54 in just a second. Okay, we still have that negative 16. I know negative 16 is technically negative 1 times 16. This negative 1, I know even though it's technically prime, it can actually be taken, I can take the cube root of that. That's what Joseph told me earlier. 16 you can break up into 4 and 4. 4 breaks into 2 and 2, and so does the other 4. So you should have had the cube root of negative 1 times 4 2's. As I write this out, how many 2's were you able to escape? How many? Just one. One big group. Only one from that group makes it out, so one big group is going to be able to try to escape. Negative 1 times 2 is going to give me negative 2 cube root of 2. So I'm going to replace both of these radicals with what I've simplified. So over here in purple, I'm going to rewrite this. 3 times the cube root of 54, which we were able to simplify, minus, Frowette told me the cube root of 2 can't simplify, and she's absolutely right, plus 7 times the cube root of negative 16, which is just what we found over here. So we're going to make this 3 cube root of 2 and negative 2 cube root of 2. Barely made it fit. So from here, we're just going to simplify just like Itzia told us a second ago. So we're going to multiply 3 times 3, which is 9 cube root of 2, minus 2 cube root of 2, and then 7 times 2 is going to give you negative 14 cube root of 2. Jenny, what can I do from here? First question, are the index and radicands the same for each? Yes. Cube root for each, and they each have a radicand of 2. Perfect. Now what can I do? Read the directions. I highlighted it. What do you do with the coefficients? You combine them. Okay, so you combine them. What's 9 minus 2 minus 14? And if you need the calculator, you have it. Negative 7. And how do I write the 2? Am I supposed to change it at all, or just keep it cube root of 2? Cube root of 2. That's your answer. For number 4, same thing. I am going to have to simplify first, unlike the last question. Well, before I move on, are there any questions on number 2? All right, for this last question, number 4, we're going to do the same thing. Remember, 72 is the square root, not the 4th root. So make sure that's a square root symbol, so ignore that 4. Okay, for here, You have space at the top. I think we can use it. We're going to split up 48. Do we need to split up the 4th root of 3? 4th root of 3. No. Why not, Kylie? It's already simplified. The only multiples you have for 3 is 1 and 3. There's no way you can make a group of 4 of the same number. And then the last part is 72. So first, find out all the prime numbers for these, and then try to simplify it. Let's write out all the prime numbers first. Since I'm doing the 4th root of 48, let me just do it now. So the 4th root of 48 is 1, 2, 3, 4 2's, and 1, 3. For 72, I'll have to do that one in just a second. I can make one group of 4 of the same number. I said this at the beginning. I don't care how many numbers you circle. You could circle 100 numbers. You are only taking out of this radical one of those 2's. So if there was 100 2's circled, you would just take out one of the 100 2's that you have. So the simplified radical for the 4th root of 48 is 2 4th root of 3. That's what I'm going to replace for the 4th root of 48. For 72, we're going to break this into 9 and 8. And then we're going to break 8 into 4 and 2. Alright, so over here to the side, we're going to make this the square root of 72, because remember, we changed this from 4th root to square root. So we're going to have 2 3 times, and you're going to have 2 3's. I'm going to group these together, help them escape. Group these together, help them escape. The index on this radical is a 2. We changed it into a square root. So this 2 goes away, so does this one. So we're going to be left with 6, because 2 times 3 is 6. Square root of 2. Remember, this 3 is grouped in here. So we have just 6 square root of 2. Down here, I'm going to replace everything I have. So we're going to have, let me write this in orange. We're going to have 7. The 4th root of 48 is this. So we're going to write this as 2 4th root of 3. Minus 2 4th root of 3. Plus 3 times the square root of 72, which is 6 square root of 2. From here, I'm going to finish simplifying. So I'm going to multiply. So 14 4th root of 3 minus 2 4th root of 3 plus 18 square root of 2. In this problem, Travis, which ones can I combine? Which ones have the same radicand and index? The 4th root of what? Of 3. So the 4th root of 3, 4th root of 3. I can combine both of those. So I'm going to subtract 14 minus 2, which is 12, 4th root of 3. Plus 18, square root of 2. Is there any possible way that I can combine this? This is like having 12x plus 18y. There's no way you can combine those. This would be your answer. It's the same thing as having 12x and 18y. They're completely different. Don't combine them. When you're ready, let's look at the next page. We're going to talk about multiplying. If this doesn't make sense, you need to say something. Alright, I find multiplying to be pretty simple, so we're going to hopefully think the same about it and now. So when you're multiplying radicals, this is the next section. When you're multiplying radicals, you're going to multiply your coefficients and then use the product rule. Your teachers probably didn't call it the product rule, they just said to multiply your radicand. So you're going to take whatever's under the same index and you're going to multiply them. So A and B could be like 2 and 4, A and B could be like x squared and y to the 3rd power. You're just going to take whatever the radicands are and multiply them. After you multiply the coefficients and the radicands, you're going to simplify. So after you multiply, you're going to simplify. In this section, I'm going to do questions 2, 3, and 5. These will go a lot quicker because they're not as crazy detailed as the other ones. So 2, 3, and 5. For question 2, first step is to multiply the coefficients, which is 3 and negative 2. And then you're going to multiply the radicands, which are 10 and 18. So the square root of 180. What do I have to do from here after you multiply? Simplify. So to simplify, you're just going to simplify this radical. So over here to the side, I'm going to simplify 180. Joseph, what multiples can I use for 180? 2 and 90. Simplify it. 2 and 45. Oh, you did the 2 route. Go ahead. Okay. Good job. You can start at 2. You can start at whatever numbers you want. As long as you get these prime numbers, I don't care how you get it. So we're going to rewrite this as, especially since it's one big square root, I could rewrite the square root underneath this. Just for the purposes of trying to be as clean as possible, I'm just going to rewrite the square root of 180 and do 2 2s, 2 3s, and 1 5. You can put it underneath here. I just like to be as clean as possible, especially since we were doing multiplication. So in this radical, I can help, since it has an index of 2, I can help these two radicals or numbers escape, and these two numbers escape since there's a group of 2. This won't make it out, and neither will this. 2 times 3 is 6 square root of 5. So in this radical, I'm going to replace it with negative 6. Instead of 180, I'm going to put 6 square root of 5. Last thing I need to do is multiply. Negative 6 times 6 is negative 36 square root of 5. That's your answer. All right, question 5, right next to it. Still sticking with square root. Still sticking with square root. This first radical doesn't have a coefficient. What's the coefficient if you don't see it? Don't say 0. 1. So it's technically saying 1 times 5. If you don't have a coefficient, you really don't need it. But this is, for question 5, 1 square root of 6 x to the 4th power. So this is just 5 outside. What's 6 times 8? 48. And then when you multiply x to the 4th and x to the 5th, what do you get? X to the 9th power. When you go back to, or when you think back to Algebra 1, when you're multiplying the same base, which in this case was x, you're going to add the exponents. Over here to the side, let's break up 48. Okay, 48 can break into 4 and 12. 4 breaks into 2 and 2. 12 can break into 4 and 3, or you could use 6 and 2. It'll give you the same answer. And then 4 breaks into 2 and 2. So underneath this radical that I have for 48, I'm also going to add in these 9s for the 7. Let's try this again. The 9 x's. So we're going to have 1, 2, 3, 4 2s, and 1 3. No, timer. You're good. Thank you. And then for the x's, we have 9 of them. So over here to the side, I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. There is a trick to this. You don't have to write this out, but I don't like giving you guys tricks unless you understand the basics. So until you can figure out that trick, you're going to have to write out all of these x's. Since the index is a 2, I can group these two together, these two together, and for the x's, I can make 1, 2, 3, 4 groups of the x's. From each of those groups that I've circled in black, only one from each of those groups is going to make it out. So from the numbers, we're going to have 2 times 2, which is 4. All right, so we had x to the 4th power. There were 4 x's. We have the square root of 3x because there's a 3 left over here and x left over here. And then I substituted in. So I replaced this right here, and I simplified it. So 5 times 4 gives me 20. Recopy the x, recopy the square root. For question 3, this one is asking you to multiply this out. So we're going to make this 54 times 5 is the cube root of 270. M to the 8 plus 4 is 12th power. So for that 270, you are going to need to simplify it. The good thing is your your radicals don't have coefficients. So there's no number to put at the front right now. So over here to the side, I'm going to break up 270. You can break that into 27 and 10. 27 can break into 9 and 3, and 9 can break into 3 and 3. 10 breaks into 5 and 2. So what I'm going to do is I'm going to replace all of this with the cube root of 1, 2, 3 3s, 1, 5, 1, 2, and I'm literally going to write out 12 m's. Until you understand the trick, I don't like giving you tricks unless you know what to do. I'm going to literally write out all 12. What's the index on this radical again? 3. So I'm going to make one group of 3, 2, 3 groups of 3, 4, and 5. From each of those groups that I circled in orange, only one of those numbers and variables is going to make it out. So over here, I'm going to rewrite this as you have a 3 that escaped. You have 1, 2, 3, 4 m's that escape. So m to the 4th power. And then for the underneath the radical, you still have that 5 times 2. 5 times 2 is going to give you 10. So over here to the side, I'm going to rewrite that. 3m to the 4th power square root of 10, because I thought there was something you would have to multiply it by, but there isn't. What's up? No, we do. What is the index? 3. And I'm going to put this in parentheses because I don't want to mistake that. If I would have done that on a test or quiz, guys, I would have literally taken a point off for even my own work. So if you don't have that cube root, so make sure it's a cube root, please make sure you put it. All right, back side of the page, or next page. I'm not going to do all of them. I'm honestly going to do 3 out of the 4 that I'd give you, but we're going to look at 15, 17, 18, and 20. For question 15, what do you think you're going to do besides panic and wish that you weren't here? What are you going to do? You can't quite combine the coefficients because these radicands aren't the same. Distribute. We would have to distribute the square root of 10 here and here. When you're multiplying radicands, thank you, Joseph, you're going to only multiply the radicands. Don't multiply the coefficients for this one. So we're going to have 5 square root of 10 times 5 under the radical is 50, minus 2 square root of 10 times 2 is 20. Ooh, 50 and 20. I think I can take the square root of those. I can't use my calculator, but I can actually simplify this. So 50 and 20. What times what gives you 50? You can do 5 times 10, or you could do 25 times 2. Why do you think I used 25 and 2? What could you do with that to simplify it quicker? 5 and 5. So the square root of 25 is just 5. So if I take the square root of 25, I'll get 5. The square root of 2 stays 2. So I can replace the square root of 50 with 5 square root of 2. What can I replace the square root of 20 with? 5 and 4? And then what can you take the square root of? The 4. I mean, you're going to have to take the square root of both, but I can't simplify the 5. So we're going to make this 2 square root of 5. So over here in blue, I'm going to rewrite the expression I have with these two pieces you just gave me. So 5 times the square root of 50 is 5 square root of 2, minus 2 times the square root of 20 is 2 square root of 5. Just like Itzia told us at the beginning, I'm going to multiply 5 times 5, which is 25 square root of 2. 2 times 2 is 4 square root of 5. Please tell me there's some way for me to combine both of these. No, I'm sorry. There's no way to combine it. I know you're like, but it's a 2 and it's a 5. There has to be a way. There isn't. This would be your final answer. Just that. With that knowledge in mind, try to do number 17. We are going to do 17 and 20. Question 18, I'm just going to talk about. So right now, start off question 17 and 20. for 17, you're technically going to need to distribute, but when we have two terms in each parentheses, we use FOIL. So you definitely need to FOIL here. So for question 17, I'm going to do FOIL for the first terms in each parentheses. So first, we're going to multiply 6 and square root of 6 times square root of 6. So 6 square root of 36. Outer is 6 square root of 6 times 2 square root of 2. So that'll be positive 6 square root of 12. For the inner terms, we're going to have negative 6 square root of 2 times square root of 6, which is negative 6 square root of 12. And then the last one, I'm going to do negative 6 square root of 2 times positive square root of 2. So that's going to give me negative 6 square root of 4. Take a second and look at it before I simplify. Know what I did to get this. You guys tell me, what can I simplify? 6 square root of 12, what happens to both of those? They do cancel. They both have the same radicand, so you would just add or subtract the numbers. 6 minus 6 cancels. Now what? There we go. This is a rare one where you actually have everything cancel pretty nicely and you get a whole number. You won't have that happen on question 18. I'm just forewarning you. So for question 17, we're going to have 36 minus 12, and 36 minus 12 is 24. For question 8, I like to go through how to set this up with you guys because I don't want you to mess this up later on your tests and quizzes and homework. What does this 2 mean? I know it means squared, but what are you supposed to do? Multiply it 2 times, separate it out, and distribute it to itself. So you need to rewrite this as 4 minus the square root of 5. 4 minus the square root of 5. Ignore that. Don't use the original because y'all love messing that up. Multiply it out as 2 separate things. So again, you would need to use FOIL. I'm not going to waste time going through that question because you guys can easily FOIL. I do want to go through a more difficult question, which is 20. So for question 20, we're going to FOIL this again. So we're going to have to FOIL this. So 18, I know you want to do it, but let's look at 20. Square root of x times square root of x is the square root of x squared because you have 2 x's. Square root of x times the square root of 2 is going to give me plus square root of 2x. Negative square root of 8 times square root of x is going to give me negative square root of 8x. And negative square root of 8 times 2, square root of 2, is going to give me negative square root of 16. Take a second and look at it. Make sure you understand how I got this. This is what I meant before with not everything's going to cancel very nicely. I do need to simplify the x squared and the 16, but let me focus on these 2 in the middle first. Ideally, I would want to combine these, but this 2x and this 8x aren't the same. I could take the square root of 8, but I can't take the square root of x. So I'm going to simplify the square root of 8x over here. Okay, so 8 I can break into 4 and 2, and then 4 breaks into 2 and 2. So if I was to simplify the square root of 8x, I would have 2 times 2 times 2 with 1x left over. How many 2's can I help escape here? Just one group. So my simplified radical for the square root of 8x is going to be replaced with 2 square root of 2x. So let me rewrite that and replace it. If you see a number that you think might be able to simplify, draw the tree. See if you can simplify it. So we're going to rewrite this as the square root of x squared plus square root of 2x. 8, we just said simplifies to what we just have in pink. So minus 2 square root of 2x minus the square root of 16. Can I combine anything here? What can I combine for what? When you subtract both of those, what are you going to get? You have a positive 1 minus 2. What's 1 minus 2? Negative 1. So we're going to have the square root of x squared minus 1 square root of x, 2x. minus the square root of 16. I could have done this simplifying of the square roots at the front and the back before, but I just waited till now. What's the square root of x squared? X minus the square root of 2x. You don't have to put the 1. What's the square root of 16? Minus 4. And I'm recopying the subtraction sign. This is my ugly answer. It looks disgusting, but it wasn't too difficult. These are the kind of answers you're probably going to see for the foiling questions like we saw above. So question 17 was unique though. All right, for dividing. For dividing, we're going to look at that piece really quick with numbers 1 and 3 on the front side, and then we're going to do a few on the back. So bear with me. For dividing. For dividing polynomials, there's 2 steps, just like multiplying. So this is also kind of one of my favorites. You're going to divide coefficients, and then you're going to use the quotient rule. What I mean by the quotient rule is you're going to take, if it has the same index, whatever that index is, and you're going to divide the 2 values or numbers that are underneath that radical. So just divide them like normal. Once you do that, simplifying by dividing your coefficients and your radicands, you're just going to simplify your final problem. I'm going to do questions 1 and 3 on that first page. For question 1, you have a calculator. Nigel, what's 12 divided by 2? And what's 160 divided by 5? You have a calculator, you can use it. So I gave you guys a calculator today, guys. 32. There we go. Nigel, do you think we could simplify the square root of 32?
Yeah.
Okay, good. Let's try it. So 32 over here to the side, I'm going to try to break it up. So just like we did before with multiplying, divide first this time, use the quotient rule, which means divide your radicands, and then simplify the radical. Okay, so 32 I can break into 2 and 16. 2 is prime. 16 I can break into 8 and 2. And then 8 I can break into 4 and 2. And then 4 I can break into 2 and 2. Okay, so for the radical for square root of 32 over here, I'm going to have 1, 2, 3, 4, 5 2's. From those numbers, or from that radical, I can help these 2's escape and these 2's escape. So underneath that radical, I'm just going to have 1, 2 left over. So my simplified radical is going to be 2 times 2, which is 4, square root of 2. So over here, I'm going to replace the square root of 32 as 4 square root of 2. Last thing I need to do is just multiply. 6 times 4 is 24 square root of 2. For question 3, when you're dividing variables with exponents, what are you supposed to do? Subtract what? The exponents. Do it. Subtract the exponents for number 3. When you're dividing variables like that with the same base, subtract the exponents. Once you have that done, you can flip over to the next page. We have a few more to do. I'm going to try to get through all of them. All right, Jory. When you divide the variables, you have to subtract the exponents. So what's 3 minus 2 on x? 1. Okay, so I'm just going to put x. And then what about y? What's the exponent going to be? Can you simplify that? You can't? Okay. What can you simplify? Because technically this means you have 1x and 1, 2, 3, 4 y's. What can you do? Don't look at me crazy. What's the index on this? 2. Yes, you can. How many y's escape? Just 2. So that one's gone, that one's gone. So what's your final answer going to be? You have 2 y's. So how would you write both of those y's? Perfect. And then square root of what's still under the radical? There you go. You know this back from Algebra 1. All right, on the last page, we're going to look at questions 2, 3, 4, 7, and 8. It sounds like a lot, but it's worth it. So 2, 3, 4, 7, and 8. All of these are over rationalizing. When you're rationalizing a denominator, you're trying to get rid of the radical that's down here. If you were taking Algebra 1 on our campus, you definitely did this. If you did it at your other campus in middle school, you might have seen it, but you definitely saw this in Algebra 1 or geometry on this campus. Okay, so for this one, the issue here when you rationalize is this little denominator of square root of 5. Whenever you're rationalizing, which I will make you do on your tests and quizzes, I'm telling you to get rid of that radical in your denominator. How would you do that? What does it mean to rationalize? Go ahead, Travis. Not square it. Close. That would be only if it's an equation. I would do the inverse. What can I do instead? Ooh, I'm about to send y'all all back to geometry and algebra 1. Go ahead, Nigel. Multiply it by the denominator. You can multiply the numerator and denominator here that I'm writing in purple. You could do it by 2 square root of 5, but really my only issue, it's not the 2, it's the 5. So I'm going to multiply the numerator and denominator by the square root of 5. You could do the 2. It'll still give you the same answer I'm about to get, but it will require you to reduce, and I don't want you to have to do that. Okay, so let's multiply it out. In the numerator, you're going to have 3 times the square root of 5. And in the denominator, you're going to have 2 times, what's 5 times 5? So square root of 25. I have a lot of students here who love using the quotient or the dividing rule for radicals, and they say, oh, Ms. Tapia, you can divide these. And I'm like, yes, you can, but don't do it. If you were to divide both of these, you're going to end up right back where you started. What could you do differently instead of dividing? Go ahead, Joseph. What is a square root of 25? So you have 2 times 5 without that radical in your denominator. That's what I want you to do. I know you guys know how to divide, but I want to make sure you can take the square root. So 2 times 5 is going to give me 10. So down here at the bottom, we're going to have 3 square root of 5 over 10. This is my final answer. You can't simplify the 3 and 10, and please don't try to divide 5 and 10 because they're not under a radical. This would be your final answer. Same thing for number 3. Nigel helped us all by saying, okay, when you're trying to rationalize, you need to get rid of the radical in the denominator by multiplying it. So for question 3, I'm going to do the same thing. I'm going to multiply this one, though, by the square root of 12. Whatever that radical is in the denominator, that's what I'm trying to get rid of. So for this question in the numerator, you're going to have to distribute. So 12 times 2 under your radical is going to be 3 square root of 24. 6 times 12 is going to become square root of 72 all over the square root of 144. Because 12 times 12 is 144. All right, the only disgusting part, we have to simplify both of these radicals. Remember, when you add or subtract, you have to simplify first. So literally up here at the top, I'm going to simplify 24. You guys simplify 72. And I want you guys to plug in, what's your simplified version going to look like for 72 and 24? Before you do that, though, what's the square root of 144, just to get that out of the way? 12. So in the denominator, I just put that 12. Simplify 72, I'll do 24. Simplify it. So I'd better be simplifying the square root of 72. I gave you what I got. Don't make me regret it. They. Were you able to get the simplified version for square root of 72? What'd you get? That's it. Beautiful. Good job. Okay, so I have this. I need to simplify it based on what they gave me, 6 square root of 2. I need to combine this to make it 6 square root of 6 plus 6 square root of 2 over 12. And I need to see if I can simplify further. The radicands, so these numbers underneath the radicals, you can't touch. But the 6, 6, and 12, can you divide those by a number to make it reduce a bit? Travis, what can you divide them all by? Bigger. 6. You can do 6. 6 divided by 6 is 1. 6 divided by 6 is 1. 12 divided by 6 is 2. So yeah, let's divide them all by 6. So this will be 1, 1, and 2. You can do 2 to start off with, but you're going to have to do it again. So down here at the bottom, here's my final answer. 1 square root of 6 plus 1 square root of 2 all over 2. That's your final answer. If you notice that you still have numbers that can still reduce, perfect, simplify it. Before I do question 4, I want you to look in your spiral and your table of contents on complex numbers. So I think for you guys, it's page 55. For everybody else watching the video, it might be something different. So for everybody in the spring of 22, this is on page 55. So flip it over to page 55. I'll give you a big hint for complex numbers. The operation I'm about to do begins with a C. What is it? Not complex. What am I going to do with that denominator to get rid of the radical? So look back in your notes. What am I going to do with that denominator to get rid of it? Begins with a C, and it's not complex. Conjugate. Good job. This is conjugate. On this page, especially for the questions the question we're about to do, you need to use the conjugate. Conjugate means that you need to take whatever's in the denominator and change it pretty much the sign from positive to negative or from negative to positive. So since this is positive, I'm going to multiply the numerator and denominator by 4 minus the square root of 2. 4 minus the square root of 2. You're going to need that in pre-cal. We literally do that the first semester. So conjugate, that means you need to take the opposite sign for what's in your denominator. What that's going to do is it's going to get rid of this radical for your denominator, because as you noticed before, we weren't adding. For questions 2 and 3, we weren't adding these in the denominator. We were just leaving them as they were. Whenever you're adding or subtracting, you have to use the conjugate. So right now, go FOIL this out. Denominator needs to be FOILed. Numerator needs to be distributed. Multiply this out. So for my numerator, I'm going to do 4 times 4, which is 16. 4 times negative square root of 2 is negative 4 square root 2. In your denominator, we did this with complex numbers. 4 times 4 is 16. 4 times negative square root 2 is negative 4 square root 2. Positive square root 2 times positive 4 is positive 4 square root 2. And then square root 2 times negative square root 2 is negative square root 4. All right, so for this, sorry about that, we had announcements. We have 4 square root 2, 4 square root 2, these cancel because they're both square root 2, one's negative, one's positive, we can cancel those. I rewrote it, so we have 16 minus the square root of 4. Square root of 4 is just 2. From here, I'm just going to subtract these two numbers to make it 14. All of these numbers, these three, are each divisible by 2. So that's why I just divided each of these by 2 to give me this pink answer. Okay, for example 7, so for this question, you have the cube root this time. When you're doing the cube root, what you're going to have to do instead, you're still going to need to rationalize, but think about it for a second. For the cube root of x, you're going to have to simplify this just a bit. So for this one, we're going to have to try to figure out how many x's we need in order to take the cube root. Okay, so think about it. How many x's do we need in order to take the cube root of x? Okay, well, in order to take the cube root of x, you actually need 3 of the same variable or number. So that's what we've been doing on all of the other pages. Whenever we were taking the cube root, we had to have 3 of the same number. So like for all of these 2's, all of these 5's, we needed 3 of the same thing. So for this one, we need the same denominator. We need 3 of the same thing. So we're going to do the cube root of x squared. The reason why I'm doing x squared for the numerator and denominator, x squared, hopefully I can write that right. The reason why I'm doing x squared is because right now I have 1. In order to get rid of all of these, this whole radical, I need to make there be 3 x's total. So I'm going to rewrite this as the cube root of x squared for the numerator, 1 times this, all over the cube root of x cubed. Okay, well, think about it. If you have x cubed and you're taking the cube root, you can help all of these x's escape, which means you just have x left over. So all I would write for my answer is the cube root of x squared over x. This would be your answer. So for question 8, same thing. What would I need to multiply underneath this cube root in order to get rid of all of these x, y, and z's? We have 2 x's already. How many more do we need in order to get rid of all of the x's? Well, we already have 2. We only need 1 more. 1 more will give me 3 x's, and as we just saw here, we can help them all escape. Y's, we have 6. Okay, well, that's a little more than I was thinking, but if you have 6 y's total and you need to make a group of 3, 6 is going to work perfectly. Z, though, we have 4 z's. I need to at least have 2 more to make it to where I can escape all of the z's. I can get rid of all of them. So let me see what I have. I have 2 cube root of xz squared for the numerator. In the denominator, be careful. We have 2 x's here, 1 x here. That is x to the 3rd power. Y to the 6th power here, no y's here, so we're going to have y to the 6th power. Z to the 4th, z squared is going to become z to the 6th power. If you need to, cube root of, we have 1, 2, 3 x's, 1, 2, 3, 4, 5, 6 y's, and 1, 2, 3, 4, 5, 6 z's. If I needed to, which I do, I need to group these in groups of 3. All of these x's, because all of these groups can escape. These are gone, so I'm going to be left with, I recopied the numerator. In the denominator, we now have an x. These y's, 1, 2, 1, 2. I have y squared for the bottom. And then the last thing for z's, these are gone, these are gone. So we're going to have z squared. This would be your answer.